Okay, children, let us start with chapter number 12, electricity. So, children, electricity plays an important role in our day-to-day life. It has many applications in domestic purpose, industries purpose, and transport sector. Children, in the homes, isn't it? Electricity is widely used to switch off the lights. For lightning purpose, we will use and also for operating fans, isn't it? And to run various equipments like TV, electronic gadgets like fridge, washing machine, oven, isn't it? These all need what? Electricity. And when we talk about the industrial sector, electricity is widely used to run machines, children, and to run motors will use, and also in the computers, to work computers in industries, electricity will be widely used. And moreover, in the office equipments, means in the office works, electricity plays an important role. And similarly, when we talk about the transport sector, electricity is widely used, especially children, nowadays in the vehicles like railway network system, isn't it, children? You have heard that metro trains, isn't it? Electronic trains are widely working with the help of what? Electricity. And also to make the charging of the batteries of electronic vehicles, electricity plays an important role. Its advantages, means applications are many, children, so we need to learn and about it. And we can't imagine our life without the electricity, children, isn't it? So in this chapter we are going to learn about what does electricity means, what it consists of, what are the factors which are involved in controlling and regulating the flow of a current through a electric circuit. We are going to study, children. So let us move into the actual syllabus, that is the topics to be covered under it or electric current and electric circuit. Means it tells us what is mean by electric current and what is mean by electric circuit. And under it, closed path or closed circuit means what, open circuit means what, we are going to study. And after that, electric potential and potential difference we are going to study. Then circuit diagrams, isn't it, children? It is often convenient to draw the diagrams instead of writing so many things, isn't it? So those all important applications we are going to study under, that is circuit diagrams we are going to study. Then Ohm's law, then factors, and resistance and resistivity means what we are going to learn. Then combination of resistors, means various types of combinations we are going to use in different electronic gadgets, that is here especially series and parallel combination we are going to study. Then after that, there is heating effect of electric current we are going to study. It's a very important, children, heating effect of electric current. You have to concentrate here more. Than applications, what are the applications of a heating effect of an electric current we will study. Then electric power means what are the units under it we are going to study. And along with all these we are going to solve what, few numerical problems. So children, in today's class, let us start with the topic first, that is electric current and electric circuit. Children, let us recall the concept called charge. In our low classes, we learned that a charge is nothing but a property of a matter which exerts what? Force. What is it, children? Charge is nothing but it is a property of matter which exerts what? Force. So let us confirm this statement, children, by making a small activity. So what we are going to do means, we are taking a plastic comb and rubbing with the dry surface, that is hair or dry surface, and bringing near the tiny pieces of paper. And what is the effect we are going to note it down, children. I have taken here a plastic comb and a tiny pieces of a paper I kept on this textbook. So when I bring a plastic, there is a comb near the papers, it is not showing any effect. But the same comb, if I rubbed with the dry surface, see here, see the magic over what is happening. When I bring after rubbing with the dry surface or hair, the pieces gets attracted towards the plastic comb. This activity clearly tells us that charge exerts a force. Initially, the plastic comb is in electrical neutral state, so it doesn't show any effect. But the same plastic comb, when it has rubbed with the dry hair, it acquired some force, children. Because of that force, the tiny pieces get attracted towards the plastic comb. Is it clear, children? The charge means what? It's a property of a matter which exerts a force. And the charge are mainly two types. That is what? Positive charge, and it is represented with the sign plus, and the negative charge, and it is represented with what? Minus sign. These are the types of charges, children. And also one there is very important properties exist between them, children. That is, positive charges, that is same charges, will repel each other. Children, the first property clearly tells us that the same type of a charges, for example, that is plus sign and plus sign, isn't it, will repel each other. Repel each other. Understanding, children? The same sign, that is plus sign or minus sign, will repel each other. See here, the same signs are there. Negative charge won't attract each other, means they are repelling. Positive sign, they'll do what? Repelling each other. And similarly, one more property says that opposite signs attract each other. What is that? Opposite meaning a plus sign will attract what? Negative sign, or a negative will attract a positive sign, and it is what do? They will attract each other. Got it, children? What is the main property it is telling? That is, positive signs, same sides will do repelling each other, whereas the opposite sign or opposite charges will make what? Attract each other. So this, why I am telling, means this is like a basic, children. Keep it in mind. Charge means what, and what are its type, and what is the property. Remember that same sides repel each other, means same charges will do repelling, whereas opposite charges will attract each other. The SI unit of a charge is Coulomb, children. It is the name of the scientist. The SI unit of charge is what, children? Coulomb. And it is often represented with capital C, isn't it, children? The SI unit of a charge is what? Coulomb. These all things you keep it in mind, children. And in our lower classes, we have studied about air currents. You know how they are formed? Due to heavy winds, we can find the air currents. Similarly, water currents also we have studied, isn't it, children? How they are formed? Due to the flowing water, we can find the water currents. In the same way, we can find what? Electric current. Then how does, means what makes this, isn't it? The flow of electric charge, nothing but electrons will constitute an electric current, children. In a circuit, that is, if we say electrical current is there, means what it means? There is what? The flow of electron is taking place over there. Let me give one example, children, here. That is, when the cells of a torch is placed in opposite terminals, means for example, positive terminal is connected to the negative terminal, means what happens? Definitely we can find the glow of a torch bulb, isn't it, children? We can find that the torch is on and the bulb gets glow. Suppose the same cells, if we keep in the same sides, means positive sign, positive terminal to positive terminal, if we keep, means what happens? It won't works. The bulb won't glow alight here. It means that opposite charges, what? They'll make a attract each other, and the electric charge means they'll start working only with the opposite terminals. In the same way, here the switch button we will use in the torch, isn't it, children? What is the role of this switch button here? Here it is acting a conducting link between the cell and the bulb. Means it is triggering, it is making that the circuit should be closed. Then only we can find what? The flow of an electric current in that. So children, let me clear about the terms switch close and switch open. When I say switch close means you have to understand that there is a flow of a current and the bulb will start glowing. And when I say the switch is open, you have to keep it in mind there is no current flows and the bulb doesn't glows. Understand children? Switch close means what I am telling, the path is closed and it is continuous one. So we can find current over there. That is the meaning of electrical circuits, children. It is clearly telling that a continuous and a closed path should be there, isn't it? When we make switch closed, we are making directly what? A continuous and a closed path. So what happens means the current flow will occurs in an electrical circuit. When I say the switch is open or broken, then we are making that the circuit is open, isn't it? So we are making that the circuit is open. So if it is open or broken means what happens? There is no continuous path. If there is no continuous path means ultimately what happens? No current flows, isn't it? If current won't flows means the bulb doesn't glows at all, isn't it, children? The simple concepts you have to understand clearly, children. Whenever the switch close, I say you have to keep it in mind there will current flows and the bulb gets on, means glow. Then when I say switch is open, you have to keep it in mind there is no flow of a current will takes place and the bulb doesn't glows. In general, let us imagine, children, when we switch on, what we are making by making a switch on, we are making a continuous path, children. That because of that reason, what happens? The fan will works or the light will run, isn't it? We can operate with the help of what? Switch button. And the same way here also, the switch close means we are making a continuous path. And when I say the switch is open, we are what? The circuit is broken, means open, means the switch on. In another terms, switch on means you can also find current flows, isn't it? And when the switch is off, what happens? We are making the circuit open. Ultimately, no current flows, isn't it, children? No current flows. So children, I'll show one small, there is a model, you can understand that is clearly, children. See here, this is a simple electrical circuit. Here what all the electrical components I have used here means, I'll say this is battery and a conducting wire. See children, you have to remember throughout this electricity chapter, when I say conducting or conducting wire or conductor, you have to imagine what? Metallic wire here, isn't it? Then which have made one side of the terminal and connected to the bulb, isn't it? And the another terminal of the bulb is get connected to the switch, and from the switch we have taken another terminal and make connected to the battery here. It means this is battery, bulb and a switch button. With these component we have made a simple electrical circuit. See what happens when I switch off. This is what switch off condition means, there is no flow of current. Suppose when I make that is switch on, isn't it? I made a switch closed, isn't it? We can find the flow of electric current throughout the electric circuit. Because of that reason, what happens? The bulb gets glow. The charge is moving, means the electrons are moving from the battery to the bulb, children. So the switch acts like a conducting link between the cell and the bulb. Got it, children, my point? Whenever the switch is closed or on, the flow of a current we can see over there. Suppose if I say the switch is off or the switch is open, there is no current flows. For example, see, isn't it? Now the switch is in open condition, means it is off, isn't it? Means it is not a continuous path. Whenever there is no continuous path, means ultimately what happens? There is no current flows in an electrical circuit. Got it, children? Is it clear, the concepts? Children, how electric current is defined, let us discuss. Electric current is nothing but the amount of electric charge flows through a particular area in given time, in a unit time, is called what here? Electric current. And in other words, it can be defined as the rate of flow of electric charge, nothing but electrons here, and it is called what? Electric current. Suppose for example, at this particular area, if how much electrons are moving in a given amount of time, and that is called what here? Electric current. How we will represent, children? Electric current, isn't it, which is equals to electric charge divided by what? Time. Here electric current is nothing but a I, then electric charge means Q, T means time. Okay, in other words, we can write I is equals to Q divided by T is the expression for electric current. See here, I is nothing but a electric current, and Q is nothing but a electric charge, T is nothing but a time, children. So how do we define electric current now? The amount of electric charge flows through a cross section in a unit time is nothing but a electric current. Now what is the SI unit of an electric current, children? That is ampere, isn't it? It is the name of the scientist who discovered the unit for a electric current, children. A stands for here unit. What it means? Ampere, isn't it, children? That SI unit of a electric current is what? Ampere here. And in general, what happens in certain cases, we will use small quantities, children. At that time, we will refer that is 1 milliampere, which is nothing but a 10 to the power of minus 3 amperes, and 1 microampere, which is nothing but a 10 to the power of minus 6 amperes, isn't it, children? Got it, children? These are smaller units of current. And here, then you can ask, you might have asked that how the direction of a current can be taken over in the electric circuit. I will tell you, children. In an electrical circuit, that is very long time back, when electricity was discovered, at that time only two types of charges were found. One is positive charge and the second one is negative charge. So at that time what they did means, the flow of current is due to flow of a positive charge, and they have taken that by conventional method, that is flow of a current will takes place from positive terminal to negative terminal. But with the discovery of electrons, what happened? A conventional method is taken in taking or in representing the direction of an electric current, children. See here, the electrons are negatively charged particles. Because of that reason, what they'll make? They'll move towards the opposite charges, means positive terminal sides they'll move, isn't it? So by conventional method, what we will take the direction of an electric current? Always the flow of a current in an electric circuit is from positive terminal to negative terminal. And in this electrical circuit, you have to understand the bigger line indicates what? Positive terminal, and the small line indicates what? Negative terminal or negative side. So how we will take, children, now the direction from positive terminal to negative terminal. Got it, children? This is all about electric current. By conventionally, we have to take the direction of the flow of a current from positive terminal to negative terminal. Got it, children? Is there any doubts? Okay. And moreover, here the see, children, there are some devices which are used specially to measure what? The flow of a current in an electric circuit. One such device here we will use is what? Ammeter. isn't it? Ammeter is a instrument which is used to measure the flow of a current in an electric circuit. That's why children, here I have used that symbol, ammeter symbol I have represented. It indicates what? It is an instrument. It measures what? The flow of a current. And remember children, an ammeter should be always connected here, series type of a connection. Got it children? Ammeter should be connected always in series connection, isn't it? So for example, if I want to measure that is resistors value, if you want to measure, means imagine that this is BC, isn't it? So what type of a connection I have to use? The ammeter should be placed here, side by side connection. Then only we can measure the flow of a current in an electric circuit. Okay children, revise these all concepts once, make it right in your fair notes, isn't it? Now we will solve a simple problems. Let's solve few easy, means simple problems we will try children. Okay, here while that is learning this chapter, so many people will say this is a difficult chapter, problems will be there, very tough it is, and all such things. You don't listen children, because when the concepts are clear, means definitely there will be a solution for that. Problem itself, what here? It's a one thing, we have to get a solution for that, isn't it? We have our own mind. If we tried, means any problem we can solve here. So children, try to solve more problems along with me. Let us start with first one. That is, an electric bulb draws a current of 0.25 amperes for 20 minutes and calculate the amount of charge that flows through the circuit is the question. See children, they are saying that when this much of a current flows in an electrical circuit in a given amount of a time, what? 20 minutes. We have to calculate what is the electric charge over there. So before solving any problem, we have to represent neatly the given data children here. What are the given data here? That is given values of a current, isn't it? Which is nothing but a 0.25 amperes. Don't forget to write the units. Definitely half marks will be there for the writing units. And what is the time children? 20 minutes. So since it is in a minutes, convert it to seconds. 1 minute will be having a 60 seconds. So 20 into 60, we have to take it as a time value. What happens? 1200 second is the time t value. Now what we have to calculate? That is Q, isn't it? Nothing but a charge is equals to, we have to calculate. So let us use the formula, isn't it? What is the formula of an electric current says children? I is equals to Q divided by T. What are the given data here? I is nothing but a 0.25 amperes. Q we don't know, isn't it? We have to calculate. And what is the T value? 1200 seconds, isn't it? When you rewrite this, means cross multiply, if it done, means what we'll get? Q is equals to 0.25 into 1200. Isn't it children? 0.25 can also be written as a 25 divided by 100. You can do directly children, but I am showing the easiest method here. 25 divided by 100 into 1200, isn't it? These two zeros get cancels. 25 into 12, which is what? 300 is the charge here. Then what is the unit of a charge here? Coulomb, isn't it children? So the amount of a charge required is how much children? That is 300 coulombs. So we can say that 300 coulombs is the charge that flows through the circuit. You have to write at last. Therefore 300 coulomb is the charge flows in an electric circuit. Got it children? Is it? Understand? what all the things they have given already in the question. You have to read once and twice, isn't it? Before solving, read the question carefully, children, and after that you have to take, that is, given values first, and the next is what formulas we have to use, isn't it? Then by substituting values we will get a charge value. Let's solve one more problem, that is calculate the number of electrons constituting 1 coulomb of a charge. We have to calculate how many electrons will constitute what? 1 coulomb of charge. So what are the given things, children? The charge is what? Q, isn't it, children? Charge Q is equals to what? 1C. We can write here. Then number of electrons we need to calculate, isn't it? How many electrons are there? We have to calculate. That can be written as N is equals to what? We have to calculate. Okay, now the charge of an electron we already know, isn't it, children? The electron possesses what? Negative charge, and its value is 1.6 into 10 to the power of minus 19 coulomb, isn't it, children? Now by using the quantization formula, Q is equals to N into I. This can also be written as N is equals to Q divided by E, isn't it, children? Here E is nothing but a electron's charge. So what is Q value? 1C. Then E value 1.6 into 10 to the power of minus 19, isn't it, children? So see, children, this can also be written as 1 divided by 16 divided by 10 into 10 to the power of minus 19. Children, here you can make rough work also here, that is 10 to the power of 19 can also be written as 10 to the power of 18 into 10 to the power of 1. Okay, children? Now if this denominator goes to numerator, means what we'll get? 10 divided by, and the denominator keep it 16 there only, then into, that is denominators 10 to the power of minus 19 goes to numerator, means its sign gets changed, isn't it, children? What it will becomes? 10 to the power of plus 19, isn't it? No need to write this plus sign here. Initially it was 19 at denominator, now it goes to numerator, means the sign gets changed, means plus 19. So how this 10 to the power of 19 we can write? 10 to the power of 18 into 10 to the power of 1. So this can also be written as, already it was there. Okay, now this 10 to the power of 19 can also be written as 10 to the power of 18 into 10 to the power of 1 divided by 16, which means that this 10 and this 10 to the power of 1 is nothing but 10. Nothing is there, means you have to imagine that it's a 1. 10 into 10, children, what it becomes? 100 into, what is the remaining? 10 to the power of 18 divided by 16. When we divide, that is 100 divided by 16, that is 16 ones are, 16 6s are, isn't it? Then 16 2s are, 5s are, isn't it? So what we will get, children? 6.25 into 10 to the power of 18 electrons will constitute what? 1 coulomb of charge. So it is clearly saying that how many electrons will be present? 6.25 into 10 to the power of electrons will be constituted in 1 coulomb of a charge, children. Just it is equivalent to what here? 1 coulomb means equivalent to 6.25 into 10 to the power of 18 electrons, children. This is like a very bigger unit, children, we can say. Okay, got it, children? How many electrons will constitute a 1 coulomb of a charge? 6.25 into 10 to the power of 18 electrons will constitute what? 1 coulomb of a charge. Children, in today's class we learned what is mean by electric circuit, electric current, what are its units, isn't it, children? Then we have solved a few simple problems. If you have any doubts, you can contact me, children, and better, that is, read the textbook thoroughly, children, isn't it? Textbook reading, you have to make it to understand the concepts more clearly. Got it, children? Okay.